Okay, now let's go ahead and take a look at examples of a significance test or a hypothesis test. All the data is here, so just make sure you're kind of, you can pause and write this stuff down, but really think about the ideas of what we're doing here. And so we have the percentage of all college graduates in the nation who have a LinkedIn account is 32%. So again, that's a claimed population parameter, 32% of the population. Now we want to test that claim, 275 graduates from one college, right? So that's a sample, right? And that would be called our sample data. And again, since our comparison to this being like a court trial, that's our evidence of either it's evidence or it's our test of the null hypothesis. And so in order to do that, what we're actually doing is we're going to double check now to see if this sample data, the p-hat, the 38% out of 275, we're going to check to see how many standard deviations above this overall percentage is this, right? And so we do the calculation and you get 2.13. And then what we're going to do in a hypothesis test is actually then calculate the probability, right, of the school having a proportion this much higher than the national rate. If that null hypothesis is correct, what's the probability of seeing evidence like this, sample data like this? And so it's a 1.6% chance, right? We would observe this sample data if the true population proportion is 0.32. And so that's all a hypothesis test is. And what we do is looking at example 6, right? Let's run through another one. You can see everything here in one shot, so you can pause and get all that information down. And so the DMV claimed 80% of its candidates passed driving tests, but a survey of 90 randomly selected teens, right, only 61 passed. And so you get the evidence here, our sample data here, right? This is the sample right here, right, is 67.8%. So if their claim is true, what's the probability we would observe a value like this or greater, right, or smaller than 67.8? What's the probability? And so that's all we're calculating. The way we write our hypothesis test, step 1, write the null and alternative, right? And so you have your H0 and you have your H0 and you have your H1, the alternative hypothesis. P is less than 0.80. This is called the formula a one proportion Z test. We're doing a Z statistic, test statistic, one proportion, because there's only one sample we're taking here and examining. We go through the IRL. We have those conditions, right? 90 is less than 5% of the population. Simple random sample. Is it large enough? We do those calculations there. Again, those are our requirements before we can run a hypothesis test. We then, the key part is calculating the test statistic, meaning that we have this p-value, right? We're saying we think it's 0.80, and then we got a sample data. We got the 0.67. So again, what's the probability that it would be this far away from our stated population parameter, 80%? And so you go through that calculation of the Z statistic, get negative 2.89, and so we're calculating the probability that the Z is less than, right, less than that value, and you get 0.0019, very low probability, which comes back to, remember here, saying here, the result is unlikely to occur, meaning that we get a low p-value. So it was a very low chance that we would see a 67.8% pass rate if this statement was true, the 0.80. And so with that, we then say, since the p-value is less than 0.05, which is our level of significance, we reject the null hypothesis. This is no good. And then we essentially are accepting the alternative. So then we say there is a sufficient evidence to support the claim that the pass rate is less than 80%. Notice that last sentence comes from here. Since the p-value of our sample data was less than 5%, we reject the null hypothesis. There is sufficient evidence to show that, and then the context of the alternative hypothesis, which is that the proportion is less than 80%. pause and then get that down. We'll look at the last example, or another example at least. This one is, oh, I should make a note that again, since it's a less than, this is a, we call it a left tail test. Make sure you make a note of that for that one there, left tail. And so on the next one, we're going to show you an example of a two-tailed test, because in our hypothesis, we're checking to see that there is no difference. There is no difference, that it's not equal, right? One that it equals 0.60 and one that it's not equal. One proportion, z-test, since it's a z-test statistic. And what we're looking at here is from this data here, 60% of graduates are prepared to manage their finances. That was a claim in 2005. In 2015, we ask 500 high school graduates, and then we find out 327, right? So the sample data now shows us that it's 65.4%. So is that, what's the probability of that getting a result like that, given that our, if the proportion was actually 60%? And so in this case here, IRL, in this case, we're going to assume it's a simple random sample. Remember, again, it has to be from a random sample for us to use these techniques. So it's something to think about, even though it explicitly doesn't state it here. We got a sample. Okay, to run it, we have to assume it's a simple random sample. 500 is less than 5% of the population of all graduates in the country, large enough. And then now we're calculating how far is 0.654, the sample data, from the stated proportion of 60. Get 2.46. Now in this case, since we're doing a no difference, right, that p is not equal, so we're just saying it's either greater than or less than, that it's not 0.60, we call this a two-tailed test. Here's 0.60. And so in this case, we're calculating the probability that z is greater than 2.46, right, our z value, and that it's less than 2.46, so it should be a negative 2.46 there, right? Or just calculate, so it's a two-tailed test. So again, what's the probability that it's greater than or less than 0.60? Okay, and so that's all we're checking here, and you get a value of 0.0137. And since the p-value is less than alpha, this is 1.3% chance, this is a 5%, we reject the null hypothesis. And so we say there is sufficient evidence to conclude that the percentage of graduates who are prepared is not 60%. Remember, we're going to use the statement in here. Since we're rejecting it, we go back to this here. We're using this one. So if we ever fail to reject, which we'll see more examples, we will say there's not enough evidence to support that alternative hypothesis.